Hello dear children. So the next topic that we are going to study is called as Biot Savart'S Law. Now if we have learned that there is a quantity called magnetic field, then it is but obvious we'll be curious to know when and where the magnetic field arises. I've told you before also, the magnetic field arises because of number 1, magnet, and number 2, current carrying conductor, meaning 2 are the things which give rise to a magnetic field. So now in this chapter we are discussing the magnetic field due to current only. So if I have a current carrying wire, then what will be the value of magnetic field due to that current carrying wire? I'll be curious to know that. So here in this particular video we'll discuss this law which gives you the value of magnetic field, but there are some limitations of this law. First will be, it is an experimental law and it was given by Biot Savart'S law. It's not exactly the limitation, but I'm just explaining the law. It is experimental law and given by Biot and Savart. It's also called as Laplace law. So actually the explanation itself is a limitation. What does it say? It deals with the magnetic field at a point due to a small current carrying element, meaning it is true for a small current carrying element. So we shall start with the law. Suppose I have some small portion of a wire. Let this be some wire. Wire's name is equal to xy. The current flowing in the wire is such that flowing from x to y, and the value of current is I. Suppose a small portion of this wire is taken. Let this portion be equal to AB and the length of this portion is dl. Now if I'll multiply it by I, then dl takes the direction of I and it becomes a vector. Length is not a vector generally, but because it takes the direction of current, hence it becomes a vector. So AB is a small current carrying element. Now let this be point P. P is my point of interest where I need to find out the value of magnetic field. I am telling you that this is the wire and tell me the value of magnetic field at point P. So what you will do, draw a position vector of P first of all. Suppose the point is here. Suppose this is the position vector written as R vector, and let theta I shall draw with the second pen. Let theta be the angle between dl vector and R vector. Then the value of magnetic field due to the small current carrying element will be small value, dB vector. So dB is found to be directly proportional to current. dB is found to be why? Because it is an experimental proof. Found to be directly proportional to dl, found to be directly proportional to sine theta, and directly proportional also to, rather inversely proportional to r square. Now if I collect all these equations, I'll say it is dB which is proportional to I dl sine theta over r square. Removing this proportionality sign, dB vector will be equal to, will be equal to mu naught upon 4 pi I dl sine theta over r square. Now this is mu naught upon 4 pi. It is a constant here where mu naught itself is termed as the magnetic permeability. And it is called as magnetic permeability of free space, right? Absolute word is also there, absolute magnetic permeability of free space. Value of this mu naught upon 4 pi be 10 to the power minus 7. You can find out the dimensions from here also, units from here also. This is mu naught over 4 pi, so its units will be Tesla, meter square, meter cancels, meter only goes there, and ampere inverse. I should write ampere inverse first and then meter, because you know a small letter written first can become milli also, na? So that's why आप ampere पहले लिखें और मीटर बाद में लिखें. अगर आप इसको पहले लिखेंगे तो ये प्रीफिक्स बन जाएगा और स्मॉल m तो मिली होता है जबकि हम इसको मीटर कह रहे हैं. So this is the value of mu naught over 4 pi. It's a constant. Its value is 10 to the power minus 4 pi. Value is 10 to the power minus 7 in the magnetism. So writing down the law again. What is Biot Savart'S law? dB is equal to mu naught over 4 pi I dl sin theta. dl is ये dl इकट्ठा है, एक साथ है, ठीक है. dl sin theta over r square. You can see what variable means what from this diagram. So if you will multiply this equation by r and divide also, then this becomes db vector is equal to mu naught over 4 pi I bahar dl cross r, because r is a vector quantity and the angle between dl and r vector was theta, so I can write it to be cross product divided by, मैंने divide भी किया था r से, so it is divided by r cube. So this is called as Biot Savart'S law and this is its vector form. You should learn the vector form also, right? So now we will discuss applications of the Biot Savart's law. In the first application itself, the application will be the magnetic field due to a straight current carrying conductor. We'll just learn its formula because now it is out of syllabus, out of 12th class syllabus, right? It is a straight wire. If you need to find out the value of magnetic field at point P, then this is out of syllabus, but we'll learn its formula. Then due to a circular loop, circular wire, carrying current, suppose this is a current carrying wire loop, current is flowing here, and what will be the value of magnetic field at its center? So we'll discuss that also using the Biot Savart's law. Then due to circular loop itself, same circular loop, carrying current, but we shall find out the value. Let this circular loop is placed here. Now it is placed perpendicular to the plane, then should be drawn like this. Current is coming out and this is the center, this is the x is passing through center, and this is your point of interest. If point of interest is center, then this diagram. If point of interest is there, then this diagram. This is on axial line and this is on center. So these three are the applications of Biot Savart's law. We'll discuss these two applications in the videos and we'll just learn the formula for this application. Thank you.